Okay, so welcome to Unit 5, Analytic Geometry. So analytic geometry is also known as coordinate geometry. So basically we look at properties of geometric objects on the XY plane, so on the coordinate plane. So your XY plane looks like this. There's X, there's Y, and geometric objects. So objects could be just lines. They could be rectangles and triangles and circles and all sorts of things. But today what we're going to look at is just lines, and we're going to look at what we call the slope of a line. We've already talked about slope before. If you remember in the last unit, we had this linear relation y equals mx plus b. And I called this M piece here the croc. Well, that's what it's called when we're looking at actual scenarios. So, we're looking at the relationship between distance and time, or number of people and cost. We call that the constant rate of change. When we're looking at it in terms of analytic geometry, so this is more theoretical. We're not looking at scenarios. We're just looking at what happens with straight lines. What kinds of things can we notice? So we call this actually the slope in analytic geometry. So croc and slope, they're the same thing, exactly the same thing, but we just call it a different thing when we're dealing with analytic geometry. Okay, so croc is the constant rate of change, and slope, which is what we're talking about today, slope is a measure of the steepness of a line. So rather than looking at how steep it is, like what angle it is in terms of degrees, we just give it a number. So however steep it is, it gets a number. And that number is called the slope. All right, so if you remember, when we were doing croc before, we calculated that as rise over run. Well, that hasn't changed at all. We also talked about it in terms of something called delta y over delta x. That triangle there, that's the Greek letter delta. And in math, we call that the change in. So the change in y divided by the change in x. How much did the y change as the x changed as well? All right, so none of that has changed. All we've really done is we've just renamed it. It's not the croc anymore, the constant rate of change. It's now called the slope. It's the same thing though. It's like a rose is a rose. It's the same thing. We're just giving it a new name. Okay, so let's take a look at the slope of a line. So we have 2 points here. So the constant rate of change is also known as the slope. Determine the slope between the points 4, 3, and -2, -6. So here's -2, -6, and here is the point 4, 3. And we're going to connect those two with a straight line using a ruler. Okay, and I want to know what's the slope of that line. What is the measurement we are going to give that line on this graph where the x and the y axis both have the same. It's important that the x and the y axis, when you're measuring slope, it kind of is important that they have the same scale. They don't always have to, but you have to kind of adjust your thinking if they don't have the same scale. Okay, so slope, again, slope, we use the letter M, that's the slope. We use the letter M, and that is rise over run. So the rise is this distance here, and the run is this distance here. We rise vertically and we run horizontally. So what is that distance right there? That's the rise. Well, goes 6 to 0, that's 6, and then 3 more, so that's a rise of 9. And then this is going to be the run, and that's 2 plus 4. That's going to be 6. That's the run, and it equals 6. So that means that the slope is going to be 9 over 6. Divide both of those by 3, and you get 3 over 2. Always reduce. always fractions when we're doing analytic geometry. Always fractions, never decimals, okay? No decimals allowed in this unit. Not for anything. Fractions all the way. Okay, so there you go. That's the slope. What we want to be able to do is we don't want to have to graph these every time we get a question. Like how daunting would that be, or how much of a waste of time would that be? So how do we get that number 9? How do we get 9 for the rise? How do we get 6 for the run? You can think about that for a second. If you want to stop the video and think about it, go ahead, think about it, and then come back. Okay, so the rise we can get by looking at the y coordinates of the 2 points. This point is the point 4, 3. This point is the point -2, -6. The 9 came about through the 6, that's your -6 there, and the 3. It's actually the difference between those two values. So really what we did is we did 3 minus -6. That's the difference between the rise or the run is the difference between your coordinates. So this y coordinate and that y coordinate give us our rise. And then for the run, we're looking at the x coordinates. The run is parallel to the x-axis, so it's dealing with the x coordinates. So we got 4 and we've got -2. Well, what would you do with 4 and -2 to get the number 6? Well, I would subtract them. So that would be 4 minus -2. That gives us 3 plus 6 over 4 plus 2 is 9 over 6, which is 3 over 2. So we're kind of developing a formula. So you subtract your y's. That's the change. So on the top here, that is our rise, which is the change in the y values. And then in the bottom, that's our x's. So that's the change in the x values. Okay? Now, it's really important that on the top, if I started with the number 3, so I started with the y in this point here, the point that's on the top right, then in the bottom, I had to start with the same x coordinate, the x coordinate from the same point. I can't switch those around. All right, so then the next page here, it looks at, well, what is that formula in general terms? So if we have any old point, x1, y1. So x1, y1, that little 1 on there, this little 1 on here, that's just telling you that it's the first point. This is the x coordinate on the first point. This is the y coordinate on the first point. And then the x2, y2, these are subscripts. They're not like exponents or anything. They're subscripts. So this is the x from the second point and the y from the second point. So the 1 and the 2 are just telling you which point you're looking at. They have no other mathematical, there's nothing mathy about them. They don't multiply, they're not squaring, they're not doing anything. They're just telling you which point it is that you're looking at. So we had to subtract our y values. So the slope is you had to subtract your y values on top. So remember back here, we took the 3 and subtracted the -6. So we subtracted the 2 y values. So I'm going to subtract y2 minus y1. I could subtract y1 minus y2 as well. It doesn't matter which. It really does not matter which. However, if you know from back here, I started with the 3 on top, so I have to go to the 4 on the bottom. They come from the same point. So in this first fraction, I've got to start with the x2 in the denominator minus x1. Or I could do x1 minus x2. Either one of these is going to work, and they're going to equal each other. But what you can't do y2 minus y1 on top and then x1 minus x2 on the bottom. You can't do that. These two numbers, the numbers that are above each other, They have to come from the same point. These come from the same point. These two come from the same point. These two come from the same point. Okay, so be careful about that. So on the next page, we just simply have the formula. This is a really important formula right here. It's just the formula that we just came up with. So slope equals y, delta y over delta x, which is the same as the rise over the run. Delta y means the change in y, and to do that, what's the change from 3 to 11? Well, you do 11 minus 3, that equals 8. So you subtract the two values to get the change in the y's, and then you subtract the two x's to get the change in the x's. Okay, so let's just do some examples. I'm going to do them first using the formula, and then we'll take a look at what they look like on the graph just to make sure we did it right. So for the first one, I'll do it in red. So for part A, slope equals y2 minus y1 over x2 minus x1. If you want, name your points. So I'm going to call this one x1, y1, and I'm going to call this point x2, y2. So there's an x and a y in each point. I have students often, they'll name one point x1, x2, and they'll name the other point y1, y2. That's not how it works. Every point needs an x and a y. It needs a horizontal number, which is your x number, and it needs a vertical number, which is your y number. So when we go ahead and we subtract these, y2 is equal to 8, y1 is equal to 3, x2 is equal to 1, x1 is equal to negative 4. Notice it's 1 subtract negative 4. So that's 5 over 1 plus 4, which is 5 over 5, and that equals 1. So the point negative 4, 3 is right here. The point 1, 8 is up here. We draw a line, a straight line, using a ruler from one point to the other. And then you can do your rise over your run, and that is 5 over 5, which is 1. All right, the next one I'm going to do in green. So negative 3. So B, why don't you try it yourself? See what you get. Stop the video, try it, and see how you do, and then come back. So x1, y1, x2, y2, slope equals negative 5 minus negative 4 over 8 minus negative 3, which is negative 5 plus 4 over 8 plus 3. That equals negative 1 over 11. That tells me that this line doesn't have a very steep slope. See how this is negative 1/11? This is 1. This one's going to be steeper. The slope that has the line segment that has a slope of 1 is going to be way steeper than the line segment that has a slope of negative 1/11. The closer the slope is to 0, the less steep it is. Okay, I'm going to write that down. The closer the slope is to 0, either positive or negative, doesn't matter, the less steep it is. Okay, so let me just double check what I just said. So negative 3, negative 4 is right here. 8, negative 5 is right here. See how not steep that is? That's not a very steep line at all. And it's falling too. What's making that fall? We talked about negative crocs and what they do. So this one is negative, so it is falling to the right. And this red one, this one is positive, so it's rising to the right. Okay, let's take a look at the next one. Do it in purple. All right, again, you go ahead, you try it yourself. x1, y1, x2, y2. Slope equals 4 minus 4 over 5 minus negative 2 equals 0 over 7. That equals 0. Well, I wonder what that looks like. because that's not positive and it's not negative. So what do you think it is? So when it's positive, it rises to the right. When it's negative, it falls to the right. What do you think it's doing if it's 0? Think about it. Okay, let's see. Negative 2, 4 is right here. 5, 4 is right here. What kind of line is that? Exactly. That is a horizontal line. So this is a horizontal. Okay? It's not rising to the right, it's not falling to the right. It's just horizontal. It's like a flat line. It's like 0. It's like you're dead. It's a flat line. Okay, last one. I'm going to do it in blue. Okay, X, you can turn it off and check it out yourself. Okay, D. Slope equals y2 minus y1 over x2 minus x1. That's negative 7 over 0. What do you get when you divide negative 7 by 0? This is negative 7 divided by 0, not 0 divided by negative 7. We've talked about this before. And try it on your calculator, see what happens. Go ahead, try it, see what you get. That's right, you got an error message. So we call this undefined, and you have to say that. You can't just leave it as negative 7 over 0. Now what kind of line is this one? Let's take a look. 1, 5 is here. 1, negative 2 is here. What kind of line is that? That's right, it's vertical. Okay, so undefined lines are vertical. Or lines that have an undefined slope are vertical lines. Okay, now if you want, you can go and do some questions on the worksheet right now and then come back and watch the rest of the video. These are just a couple of little applications of slope. So example 2, suppose the slope of the line between the points is 4/5. If one of the points is 2, 12, find the x-coordinate of the point where y equals 4. So basically it looks like this. We've got this 2, and let's say that's 12. 2 and 12, and there's a point right there. And then we've got the point 4. And it's going somewhere. And I know that the slope is equal to 4/5. So remember, this is rise and this is run. Oh, sorry. I got that backwards. Hold on. Oh, what am I doing? There we go. It's not the x that's equal to 4. So, oh. Okay. It's the y value that's equal to 4. So the rise is 4. The run is 5. So whenever it rises by 4, so rises by 4, you run by 5. Well, then that means if I fall by 4, I got to go back 5. And I fall by 4, and I got to go back 5. I didn't draw this very well. And I don't think I can move this over. No, I can't. Nope. Don't know how to do it. I don't know how to work this software. Okay, so I got some line here, and eventually it's going to hit 4. Somewhere back here it's going to hit 4. Here, let me draw it over here. Here's 2, here's 12. And then there's a y-coordinate of 4. And this is going up 4 and over 5. Or it's coming down 4 and going back 5. So it's doing something like this. The question is, what's that coordinate right there? That's what we're trying to find. Okay, so we're going to use the formula to do that. So slope equals y2 minus y1 over x2 minus x1. We know that the slope equals 4/5. The question told us that. We know that one of the points is 2, 12. I'm going to call that one x1, y1. We also know that the other point has a y-coordinate of 4, and I don't know what the x-coordinate is, so I'm just going to call it x. This is going to be x2 and y2. So 4/5 equals y2, which is 12, nope, which is 4, minus y1, which is 12, over x2, which is x, minus x1, which is 2. So 4/5 equals -8 over x minus 2. To solve this, what we're going to do is we're going to cross multiply. So 4 times x minus 2 equals 5 times -8. That's called cross multiplying. So expanding this bracket out, that gives you 4x minus 8. You got to multiply both the x and the minus 2 by 4. And that equals -40. Bring the -8 to the other sides. 4x equals minus 40 plus 8. 4x equals -32. I'm just going to come up here because it's the end of my page. So 4x equals -32. Divide both sides by 4, so x equals -8. So this right here, that is -8. This is the point for -8. Okay? So this is the only formula you know right now that has anything to do with slope, so that's the formula you're going to use. The next question is a little bit more involved. Let's just take a look at what this looks like. So line A and line B intersect at the point 5, 2. 5, 2. 5, 2. Notice I'm just doing a sketch. Another point on line B is 3, 1. So here's 3, there's 1. So this line here that goes through those 2 points is line B. Line A also goes through this point here, but it has the slope of line A is the negative reciprocal of line B. Well, what's the slope of line B? So the slope, let me do this in red. The slope of line B. Well, I have 2 points on line B. I have the point 5, 2 and the point 3, 1. So let's do the slope between them. Y2 minus y1 over x2 minus x1 equals 1/2. So that means that the slope of line A is the negative reciprocal of that. So the negative of that, so that'll be a negative, and reciprocal means flip it over. So that would be the negative of 2 over 1. It's like flipping when you do division of fractions. Okay, so that's the slope. So -2 over 1, which is the same as -2. I'm probably going to leave it as -2 over 1. Because now I've got a similar question that we had before. So -2 over 1, that's a drop of 2 for every run of 1. So I'm going to go down 2. This is at 2, and I'm going to go down 2 and over 1. And then you can go down 2 and over 1. And then you can go up 2 and you can go back 1. So this line is going to look like this. This is line A. All right, now it says find the y. See, I haven't even read the whole question yet. All I'm doing is I'm reading what's there and I'm drawing a diagram. If I just went and I read that question, I just wouldn't even know what to do. I've got to break it apart. So you should be doing this with every question you get. You break it apart, draw a picture of what's going on, and that will help you figure out what to do to solve it. So this time we want to find the y-coordinate. In this last question, we wanted to find the x-coordinate. All right, so we want to find the y-coordinate this time when the x-coordinate is 11. So if I go way over here at 11, the x-coordinate is 11. This line's going to keep going, And at some point, there's going to be a point where the x coordinate is 11, and the question is, what's the y coordinate? So we're going to do it the same way we did the last question. We know this point is on that line. The point 52 is on that line. So I'm going to call that one x1, y1. And I'm going to call this x2, y2. And I know that that's got to equal the slope of A, which is -2. So y2 is y minus y1 is 2 over x2 is 11 minus x1 is 5. That has to equal -2 over 1. That negative sign has to go with the 2 or the 1, but it can't go with both. You have to make a decision. Okay? So y minus 2 over 6 equals -2 over 1. Cross multiplying, you got 1 times y minus 2 equals -2 times 6. Come up here, so that's y minus 2 equals -12. Bring the 2 over, add that, y is going to equal -10. And see how when we draw a picture of what's going on, there's the y value of -10. When we draw a picture of what's going on, we can check and see if our answer is reasonable. If you don't draw a picture, then you have no idea if your answer is reasonable at all. Okay, so that's that. There is no more. There's the worksheet for you to do. There's a couple questions like these last two, and there might be some other questions on there too that might be a bit of thinkers. As always, if you have any questions, please let me know. Okay, contact me. I'll help you out.